Let me extend a welcome to everybody. There are plenty of seats over here on the front if you want to come up. My name is George Handley. I'm a representative of a faculty initiative called the Environmental Ethics Initiative, which is a joint venture between BYU faculty, the Nature Conservancy, to help sponsor a series of lectures that have been going on since last fall on environmental ethics, and today's presentation is part of that series. So we're very grateful to the Nature Conservancy for sponsoring today's lecture, and of course to the Kennedy Center for housing us here and helping us with publicity and other matters and their ongoing support. We have another lecture in this series coming up in a couple of weeks on March 27th. That's a Tuesday at 2 p.m. Peter Kariva, who is now I've forgotten if he's the head chief scientist of the Nature Conservancy, who will be here on campus to give a lecture and that will be in 3711 in the Harold B. Lee Library. We also are going to sponsor a symposium for the fall semester. For those of you who are still going to be around in the fall, November 8th to the 10th, we're going to have a symposium focusing on conservation, restoration, and sustainability, a call to stewardship. It's an interdisciplinary conference. We'll have some exciting keynote speakers and some great panels and presentations from a variety of disciplinary perspectives on stewardship. Today's lecture is Naomi Oreskes, and we're very pleased to have her here. She is the author most recently of Merchants of Doubt, How a Handful of Scientists Obscured the Truth on Issues from Tobacco to Global Warming, that is co-authored with Eric Conway. This book was shortlisted on the Los Angeles Times Book Prize, and her opinion pieces have appeared in the Times, London, the Washington Post, Los Angeles Times, Nature Science, the New Statesman, and other venues. She has a long-standing interest in understanding the establishment of scientific consensus and the role and character of scientific dissent, and her early work examined the 20th century transformation of science in a book called Plate Tectonics, An Insider's History of the Modern Theory of the Earth, and in another book, Rejection, Continental Drift, Theory and Method in American Earth Science. She is currently a professor of history and science studies at the University of California, San Diego, and adjunct professor of geosciences at the Scripps Institution of Oceanography. So we're very pleased to have her here, and before I turn the time over to her, I should also mention that we tried to have copies of her book here for the presentation. Apparently there was a little bit of a delay, but we understand there are extra copies of Merchants of Doubt that will be available in the bookstore, if not first thing tomorrow. So if you're interested, I highly recommend this book. I think it's one of the most important books you'll read about the fate of science in contemporary American life and the politics of the dissemination of scientific information in our country. And so I leave that recommendation to you. I would like to ask Professor Chip Oscarson if he wouldn't mind come up and give an opening prayer, and then we'll turn the time over to Professor Oreskes.
Well, thank you so much. It's really a pleasure to be here in so many ways. And I want to especially thank you for that beautiful prayer, which summed up a lot of how I feel about this issue. And it's a pleasure to be here for lots of reasons. I had the opportunity to speak here at BYU a few years ago and brought my daughters. And my daughter Clara still thinks it was one of the best days of her life because she got to excavate a dinosaur bone. So, and then she asked me on the way home if she could go to BYU, and I said, well, you can if you want to, but there aren't too many Reconstructionist Jews at BYU. But, you know, but we like to be open-minded about these things. So in any case, she is planning to go to college and wants to play field hockey. I don't know if you have field hockey here, but you can tell me afterwards if you do. It's also really nice to be here because one of the things that's upsetting about the way in which climate change has become politicized in the United States in recent years is this idea that somehow a religious Christian would reject the scientific evidence of climate change, or that a religious Christian wouldn't believe in climate change. I find those to be quite remarkable and rather worrisome positions for people to take. So I do think it's extremely important for people of faith to understand the scientific basis for concern about what's happening to our planet, and to understand that many people who work on climate change issues are people of faith, and that no matter what your position is vis-a-vis those kinds of questions, this is an issue that all of us as citizens of the United States and the planet ought to know about and be knowledgeable about. What I've done today is this is about talk number 100 since the book came out. I've talked about this issue in a lot of different forums, in a lot of different places. I have a lot of different versions of the talk. I have long versions, I have short versions, I have faith-based versions, I have non-faith-based versions. But what I wanted to do today was to leave a lot of time for questions. So I've actually chosen today to give my shortest version of the talk. It's only about 35 minutes, and I'm going to try to leave as much time as possible for questions, because I know people have a lot of questions, and I think, particularly here at BYU, there's a lot of really interesting things that we can talk about. So with that, I'll try to get started. So for me, this whole story had a number of beginnings, but one of them was in 2005, when my Governor Arnold Schwarzenegger of California, announced that the state of California was going to pass a bill, or he would try to pass a bill, to commit the state of California to controlling greenhouse gas emissions. And when he made the announcement for what is now AB 32, which is now, in fact, the law of the land, many people don't know that the state of California has an emissions trading program to control carbon dioxide. Governor Schwarzenegger said the following: "I say the debate is over. We know the science, we see the threat, and we know the time for action is now." Well, I was rather impressed by that, because it's not every day you get to agree with a politician. And it seemed to me that my governor was correct about the state of the science. And moreover, it seemed that in the mid-2000s, around that time, most of the American people agreed. So a number of opinion polls that were done at that time showed that the vast majority of Americans accepted that climate change was in fact underway. The Yale Project on Climate Change, working with the Gallup polling organization, showed that 72% of Americans were completely or convinced that global warming was happening. Moreover, 62% of us believe that life on Earth would continue without major disruptions only if society takes immediate and drastic action to reduce global warming. And indeed, at that time, even many former contrarians had come around. So people who had previously expressed skepticism about the issue seemed to be finally coming to understand it. So one of them that caught my notice was a man by the name of Frank Luntz, a Republican strategist, who in an interview in 2006 said, "It's now 2006. So he was off to a good start. He got the year right. "I think most people would conclude that there is global warming taking place, and that the behavior of humans is affecting the climate." Now, Luntz was important, famous, some people might say infamous, because he was the author of a memo to Republican candidates running for public office in 2003, in which he advised them to use the phrase climate change rather than global warming, because he said climate change is a lot less frightening than global warming. Public opinion polls consistently showed that the majority of Americans did say that they cared about protecting the environment, and did believe that protecting the environment was an appropriate job of government. But it also showed that Republicans were more vulnerable on the issue than Democrats, because Republicans were perceived in general to be less willing to take steps to protect the environment than Democrats were. And so Luntz was responding to that information. But he went further. He also advised the Republican candidates running for office to emphasize scientific uncertainty, and to say, contra Governor Schwarzenegger, that there wasn't a consensus, that we didn't know the science, that it wasn't clear, and that in fact the scientific debate still remained open. And he wrote, and all of the emphasis here is here, "The scientific debate remains open. Voters believe there is no consensus about global warming within the scientific community. Should the public come to believe that the scientific issues are settled, their views about global warming will change accordingly. Therefore, you need to continue to make the lack of scientific certainty a primary issue in the debate." So we see the question of scientific uncertainty being used as an explicit political tool, and Luntz goes on to say that there's still a window of opportunity to convince the American people, but that window of opportunity is closing. Now, we can ask the question, was Luntz's position factually correct? Was the debate still open in 2006? Well, the short answer is no, not among scientists, not among the people who actually study the Earth's climate system. Among those people, they had concluded in 2001 that human activities were modifying the concentration of atmospheric constituents that absorb or scatter radiant energy. Most of the observed warming over the last 50 years is likely to have been due to the increase in greenhouse gas concentrations. That was the Intergovernmental Panel on Climate Change in 2001, the US National Academy of Sciences, the Royal Society in Britain, and virtually every other major scientific society around the globe had said essentially the same thing. Indeed, the science had actually coalesced even earlier than 2001. In 1995, the IPCC had issued its second assessment report on the question of human-caused climate change and had come to the conclusion at that time that the balance of evidence suggests a discernible human impact on global climate. Now, as a historian of science, I had become interested in this question of whether there was or wasn't agreement in the scientific community, because the scientists were saying there was agreement, but politicians were saying there wasn't. So I did an analysis of the published peer-reviewed scientific journals using the Institute for Scientific Information database. And by analyzing the published literature, I was able to show that indeed the IPCC conclusion, the conclusion of the US National Academy of Sciences, which was also the conclusion of the Environmental Protection Agency, was consistent with what was published in the peer-reviewed scientific journal. In other words, there was a consensus among scientists that climate change was happening and that it was mostly being caused by human activities, the increase in greenhouse gases in the atmosphere, which were altering the radiative balance, that is to say, altering the heat balance of the atmosphere. So I published this result in Science magazine. I've forgotten what year this was, 2004, I think. And when this was published, I started getting a lot of very peculiar email. And a lot of people, the polite way of saying it is that my result surprised a lot of people. And that was interesting to me, that this result should be considered so surprising, because it really should not have been considered surprising at all. The reason it should not have been surprising was because the United States is a signatory to the UN Framework Convention on Climate Change, which we signed, along with 193 other signatories, in 1992. The UN Framework Convention commits the United States and all of the other signatories to acting to prevent dangerous anthropogenic interference in the climate system. The whole reason the Framework Convention exists, the reason why our first President Bush signed the Framework Convention, was because the scientific evidence was already coming together, even at that early date, to say that human activities were already beginning to alter the heat balance of the atmosphere in ways that could be dangerous, ways that could affect the welfare of both people here in the United States and around the globe, and also the welfare of other non-human species with whom we share the planet. And the Framework Convention actually has a lot of conversation about biodiversity as well. When President Bush signed the Framework Convention on Climate Change, he called on world leaders to translate the written document into concrete action to protect the planet. So at that moment in 1992, it appeared that political leaders understood the science, understood the threat, as Arnold Schwarzenegger said some years later, and that the time for action was already now. But that didn't happen. So as a historian, I became interested in the question, why? What happened? What happened to that understanding, that scientific understanding, that political understanding? And why didn't we take those concrete steps that our first President Bush promised us back in 1992? Some of you students probably weren't even born then, you know? This is like ancient history. Sometimes my colleagues in history criticize me. They think, well, this is so recent. How can this be history, right? And I say, well, I just tell my freshmen, and they think it's history. So what I want to do this morning is to give you a super, super brief, abbreviated history of the evolution of climate science, the science that brought us to the point of the UN Framework Convention, and then tell the story that Eric Conway and I tell in our book, Merchants of Doubt, of a politically motivated challenge to that science. It's a story of selling uncertainty along the lines of that Luntz memo, of emphasizing doubt in order to prevent political action. And it's based not on science, not on flaws in the science, but on political ideology that was born in the Cold War, but that lived on long after the Cold War was over. So the story of the scientific investigation of carbon dioxide as a greenhouse gas really begins with this man, John Tyndall, the Irish experimentalist who first demonstrated that carbon dioxide is a greenhouse gas. And by that, he meant what he discovered was that it had this highly distinctive property of being essentially transparent to visible light, but fairly opaque to infrared. So sunlight comes in from outer space, warms the planet, and the carbon dioxide in the planet traps that heat and keeps our planet warm. And Tyndall recognized that this was a good thing because without carbon dioxide, the Earth would be as cold as the Moon or Mars and completely inhospitable for life. Conversely, if we have too much carbon dioxide in the atmosphere, we could end up like Venus, which has a runaway greenhouse effect and is so hot that spaceships can't even land there. Now, Tyndall first did this work in the 1850s. When people sometimes tell me that climate change is a big conspiracy, I say, well, if it is a conspiracy, it began in Dublin, Ireland in 1850. The first person to begin to think of what would happen if we changed the amount of carbon dioxide in the atmosphere was the Swedish geochemist Svante Arrhenius. So the conspiracy now has to move to Sweden. In the early 1900s, Arrhenius was the first person who recognized that when you burn fossil fuels, particularly coal, it releases carbon dioxide to the atmosphere, and that by burning coal, we could be increasing the amount of carbon dioxide in the atmosphere in a way that could change the planet's climate. Arrhenius did the first calculations of what would happen to the Earth's climate if we doubled the amount of carbon dioxide in the atmosphere and concluded that it would warm the Earth by 1.5 to 4.5 degrees centigrade. Now, he was Swedish, so he thought warming would be a good thing. The first person to suggest that it might be a bad thing was the British steam engineer Guy Stewart Callendar, who picked up the question that Arrhenius had raised and began to publish articles in peer-reviewed scientific journals suggesting that if you actually measured CO2 in the atmosphere, which some people were beginning to do at that time, that there was already a small detectable increase, and he argued that there was already a small detectable temperature increase as well. Now, that was in the late 1930s. He was in England. War broke out in Europe. He was unable to continue the research, and the question got dropped for about 20 years. One important reason it got dropped as well, though, besides the intervention of World War II, was that some scientists looking at the question at the time said, well, it is true that carbon dioxide is a greenhouse gas, and it is true that if you increase it, it might affect the climate. But water vapor is a greenhouse gas too, and there's much more water vapor in the atmosphere than there is carbon dioxide, so it seems unlikely that a small change in carbon dioxide could have a very big effect. Now, this might seem like a small technicality, and I wouldn't raise this issue except for the fact that some of you may know this question gets raised again today by climate skeptics and contrarians and deniers who want to claim that it doesn't matter if carbon dioxide is increasing because it will have no effect because there's so much water vapor in the atmosphere. So if you hear that complaint made, and you can find it on the internet, it's very, very common, I think it's important for you to know that scientists have looked at that question, and in fact, they answered that question more than 50 years ago. In fact, they answered it before I was even born. That work was done by Gilbert Plass, who was a pioneer in upper atmosphere spectroscopy. He was the first man to use satellite data to analyze the composition of the atmosphere and its impact on the heat balance of the Earth. And what he was able to show is that, yes, there is a lot of water vapor in the atmosphere, but the absorption bands, that is to say the wavelengths in which water absorbs water absorbs heat, are different than the wavelengths where CO2 absorbs heat. So even though there is a lot of water vapor in the atmosphere, it doesn't overwhelm the effect of CO2. So once this work was done, this was a very important piece of work because many scientists at that point said, oh, Callendar's probably right. Carbon dioxide does matter, and we need to start paying more attention to it. And that happened in 1957 as part of the International Geophysical Year. So these two men were professors at the University of California. On the right, Roger Revelle. On the left, Hans Suess, both oceanographers, chemical oceanographers. And in 1957, they published an article in the peer-reviewed journal Tellus in which they argued that by burning fossil fuels and putting carbon dioxide into the atmosphere, we, mankind, was performing a great geophysical experiment, an experiment that could have far-reaching ramifications. and therefore that they, as scientists, should be paying more attention to this question, and particularly should begin to measure, to carefully measure the amount of carbon dioxide in the atmosphere to see if indeed it was rising. So they raised the funds to do that as part of the International Geophysical Year with cooperation from scientists around the globe. And the man who undertook that work and made it his life's calling was this man, Charles David Keeling, who I had the privilege to know at the University of California until he died a few years ago. In 1958, as part of the International Geophysical Year, the Keeling curve was born. It's also the year I was born, so I like there's a kind of nice little historical confluence there. So I was born along with the Keeling curve. Already by 1965, Dave Keeling had concluded that there was indeed a detectable increase in the amount of carbon dioxide in the atmosphere. I have a pointer, I forgot to take it out, but if you just look at this part of the slide here, so already by 1965, when Dave started the measurements, they were 312. When he started 318 by 1965, and even though that's a small amount, only 3 parts per million, one of the questions was whether you could detect this at all. And so he was actually very excited that within only a few years, he was able to show that, yes, indeed, carbon dioxide was rising. You could measure it. You could detect it. You could also detect the seasonal variation in carbon dioxide based on plant activity, mostly in the northern hemisphere. And so one of the things that Dave did during the course of his life was to demonstrate both the seasonal variability, the annual cycles, and also the long-term trend. So this annual cycle is completely natural. This is because of plants. This long-term trend, though, is what this issue is all about. So in 1965, as part of the President's Science Advisory Committee, Revell, Keeling, and some other scientists wrote what was one of the first warnings that if we didn't pay attention to this, it could become a serious social, economic, and political problem. And they wrote, by the year 2000, there will be about 25% more CO2 in our atmosphere than at present, and this will modify the heat balance of the atmosphere to such an extent that marked changes in climate could occur. And they go on to say that these changes in climate could cause sea level rise that could drown cities. It could have impacts on agriculture that could lead to disruptions in food supply. It could alter precipitation that could lead to droughts and floods. All of the things that we now know have already indeed begun to occur. And indeed, at least one politician was listening. In 1965, President Lyndon Johnson, in a special message to Congress, said, "This generation has altered the composition of the atmosphere on a global scale through a steady increase in carbon dioxide from the burning of fossil fuels." So already in 1965, we knew that carbon dioxide was rising. We knew it was coming from burning fossil fuels. And at least one president of the United States, well, actually several presidents of the United States, knew about it, understood it, and talked about it. Now, although President Johnson did talk about it, he talked about a lot of things, and he also had some other things to worry about in 1965. So not much serious interest was generated in the question in policy circles in the 1960s. But that changed in the 1970s with the rise of numerical simulation modeling, the construction of large-scale computers to look in more detail at how the climate system really worked. And this work led to a very significant amount of discussion about the possibility of climate change in policy circles. In the book, we talk more about some of the discussions that took place, but a whole series of reports that begins to be written at the Department of Energy, at NOAA, the National Oceanic and Atmospheric Administration, at the U.S. National Research Council. And again, notice, none of these are environmental activist groups. The Department of Energy, the Jason Committee was a group of high-level physicists who mostly advised DOE on weapons and military questions, National Research Council. So a wide variety of people in different domains beginning to talk about this as an energy issue, a security issue, an economic issue. These various different studies led the National Academy of Sciences to say in 1979 that a plethora of studies from diverse sources indicates a consensus that climate changes will result from man's combustion of fossil fuels and changes in land use. So I first became interested in this because I was interested in the question of scientific consensus. And here we see scientists using that word themselves, the word consensus, to describe a state of affairs in 1979. That is to say, we already knew on the basis of scientific evidence in 1979 that climate change would result from burning fossil fuels and changing land use, mostly deforestation. Now, when I talk about this consensus, I like to point out that this is a consensus about an expectation, about a prediction. It's a scientific prediction in the classic if-then form. If we continue to combust fossil fuels, then climate changes will result. So there was a consensus that about a prediction, about an expectation of what we would expect to happen based on the laws of physics and chemistry. What there wasn't yet a consensus about at that time was when this would happen. Okay, so I've already said that. Oh, sorry, I should also point out there was also a consensus that it was not a trivial matter. So, for example, the National Research Council wrote, "The close linkage between man's welfare and the climatic regime within which his society has evolved suggests that such climatic changes would have profound impacts on human society." And again, this is something we see challenged all the time now. People say, oh, a little bit of climate change, big deal, a degree or two, so what, you know, it'll be 70 instead of 68. No, this is about changing the whole climate of the whole globe in ways that will impact agriculture, water resources, sea level, and all of this was already understood in 1979. None of this is new science. But what was new, what wasn't resolved at that time was when. When were any of these changes expected to occur? And most scientists who were writing at that time didn't think that climate change was imminent. Most of them thought that changes would begin to become detectable in the 21st century. In fact, one scientist I interviewed told a great story of going to the Carter White House to brief officials on this question, and he was asked by one of the officials, well, when is all this going to happen? You know, you're talking about all these charts and graphs and doubling CO2. Give me a number. When is this going to happen? And the scientist said, well, you know, we don't really know for sure, but maybe 40 years. And the official said, please come back in 39. So scientists were surprised when it happened a lot faster, when in fact changes became detectable only a few years later. In 1988, a team at NASA, the Goddard Institute for Space Studies, led by Jim Hansen, who originally from Iowa State, again, not a radical environmentalist. Hansen always likes to point out that he was raised an Iowa farm boy. He and his team, based on an analysis of temperature records and physical models of the atmosphere, concluded that climate change caused by human activities was, in fact, underway. And he testified to this in Congress in 1988, saying that he was 99% certain that, in fact, climate change was now detectable. And if anybody's interested in how he came to that conclusion, we can talk more about that in the Q&A. One reason that Jim Hansen is such a worried man now and has really become radicalized by this experience, and he got arrested protesting the tar stands a few weeks ago, is because you know, he stands up in public, he says, we've known this for 30 years and we've done nothing about it. I spent 30 years in a suit and tie trying to talk calmly and rationally about this, and nothing happened. So now he says, I'm taking off my suit and tie and getting arrested. It's kind of an interesting evolution for an Iowa farm boy. So it's this emerging evidence that climate change is happening faster than people anticipated that leads then, in large part, to the creation of the IPCC, the Intergovernmental Panel on Climate Change, in 1988. But it also led to something else. It led to the emergence of a politically motivated campaign to cast doubt on that emerging scientific consensus, to challenge the science, to challenge the scientific evidence, by focusing on the claim that there wasn't a consensus, that the science was unsettled, and therefore it would be premature for governments or individuals to act to do anything about the issue. So as a historian, I'm interested in origins, I'm interested in where things come from and how they evolve and change over time. And so one of the tasks that Eric Conway and I set for ourselves in this book was to try to understand where this came from. What was the story that led to a situation where Governor Schwarzenegger would say, we know the science, and Frank Luntz would say, we don't? Well, today, as you know, doubt about climate change is promoted in many quarters, including in the State House here in Utah. But one of the most important sources of skeptical claims about climate change, going back to 1988, going back to that very moment when Jim Hansen testified in Congress, is a think tank in Washington, D.C. called the George C. Marshall Institute. For many years, the Marshall Institute denied the reality of climate change, initially denying it was happening at all, then saying, well, if it is happening, it's caused by natural variability, and then saying, well, even if it's not natural variability, it'll be good for us. Carbon dioxide is great, and don't worry. So where did the Marshall Institute come from? And why do they promote doubt about climate science? Why do they deny this 150 years of scientific research? The Marshall Institute was founded by three men, all physicists who had built their careers and made their names in the Cold War working on US rocketry and weapons programs. The person whose idea it was for the institute in the first place was an astrophysicist by the name of Robert Jastrow, who was the head of the Goddard Institute for Space Studies at NASA, and ironically was Jim Hansen's boss. On the right, William Nierenberg, a nuclear physicist who had worked on the Manhattan Project, helped build the atomic bomb when he was a young man, and then spent the rest of his career working closely with the US Navy on Cold War programs related to Soviet submarine surveillance and detection. And in the middle, Frederick Seitz, a solid-state physicist who had helped build the hydrogen bomb, had also worked closely with the US Army on many different weapons programs, and was one of the presidents of the US National Academy of Sciences in the 1960s, also became the president of the Rockefeller University. So these were all three extremely distinguished men, highly intelligent, even brilliant, men who had operated on the very highest levels of American science and science policy, men whose advice had been sought by presidents, admirals, generals, senators, congressmen. And at this point in their life, though, also all either retired or on the verge of retirement. In the early 1980s, the three of them found themselves working together on an advisory panel to the Reagan administration on the question of strategic defense, or what most of us know of as Star Wars. As some of you are old enough to remember, Ronald Reagan proposed building a missile defense shield, what he called the Strategic Defense Initiative, to protect the United States from incoming Soviet weapons. And when the Reagan administration talked about this idea, they also sometimes talked about a winnable nuclear war. Well, this mobilized a lot of opposition in the scientific community, including in the weapons community among many people who had built nuclear weapons, because it was really a kind of abrogation of the Cold War policy of mutual assured destruction, where we all agreed, we won't bomb you if you don't bomb us, because that would be a really dumb idea. But the Reagan administration started speaking in other language, and it caused an enormous reaction in the scientific community. Over 6,500 American scientists and engineers signed a petition pledging not to work on the Strategic Defense Initiative because it would be politically destabilizing and could lead to a World War III. Jastrow, Nierenberg, and Seitz were a tiny minority in the scientific community in that they supported the Strategic Defense Initiative. They created the Marshall Institute in 1984 specifically for the purpose of defending SDI against this large-scale scientific opposition, and to continue to promote the importance of science and technology in national defense. Now, of course, they were entitled to their opinion, but one of the things that they did then was to start demanding equal time for their views. So a major part of their work was challenging Carl Sagan and Hans Bethe, who had organized the opposition to SDI. In the book, we also talk about another debate they had with Carl Sagan over nuclear winter. So Sagan and Bethe were getting a lot of press representing these 6,500 scientists. So what Jastrow, Seitz, and Nierenberg do, they would call editors and newspapers and demand equal time for their view. And if they didn't get equal time for their view, even though there were 3 of them and 6,500 of the others, 6,502, if they didn't get equal time, they would threaten to sue under the Fairness Doctrine. So they put a lot of pressure on newspaper reporters and editors on this issue. They also began to write articles of their own, painting a very frightening picture of American weakness, insisting that the United States was on the verge of being taken over by the Soviet Union, and that if we didn't act soon to defend ourselves against this renewed Soviet threat, well, there you have it. America has 5 years left. That was in 1987, and I'm happy to report that this is one scientific prediction that did not come true. In fact, it was actually the opposite. We know now in hindsight that Jastrow's estimates of Soviet strength were grossly exaggerated. It was only 2 years later that the Soviet Union began to disintegrate. Now, at the time that all of this was happening, Frederick Seitz had retired from the Rockefeller University, and he had taken on one last job in his retirement, and that was working as a consultant to the R.J. Reynolds Corporation. As some of you know, and as we talk about in the first chapter of our book, the principal strategy that the tobacco industry used to persuade people that tobacco smoking was safe and not harmful and not bad was doubt-mongering, to challenge the scientific evidence of the harms, to insist that the science was unsettled and that we didn't really know whether or not tobacco was harmful, and therefore it would be wrong for the government, states, local municipalities, or the airlines for that matter, to limit smoking in public places. In 1989, these two stories merged. So Seitz is working for R.J. Reynolds, learning the doubt-mongering strategy, and the Cold War, which the Marshall Institute had been set up in response to, ends. When the Cold War ends, the Soviet Union disintegrates. So the whole raison d'etre, everything that these men had done, everything they'd fought for, well, you might have thought that they would have been happy, that in fact the United States won the Cold War, and that everything they had fought for had worked out the way they wanted. But instead of being happy, instead of retiring and playing golf, they found a new enemy. It was like they were like generals who couldn't stop fighting. And that new enemy was what they called environmental extremism. What they claimed was the exaggeration of environmental threats by people with a left-wing socialist or communist agenda. So in a sense, they turned environmentalists into communists. They replaced the Soviet Union as the Red Menace with environmentalists in the United States. And drawing on the experience that Seitz had working with R.J. Reynolds Tobacco, they applied the tobacco strategy, insisting that the science was unsettled, that just as we didn't really know if tobacco was harmful, we didn't really know whether or not climate change would be harmful either. Doubt is our product, ran the infamous memo written by one tobacco industry executive in 1969, since it is the best means of competing with the body of fact that exists in the minds of the general public. Well, if doubt was the product, these scientists supplied it. But as we show in the book, not just about the harms of tobacco, but also about the threat of nuclear winter, the reality of acid rain, the severity of the ozone hole, and the causes and consequences of global warming. So a kind of litany of issues that they become involved with. More recently, there's been a kind of revisionist attack on the science related to DDT, and if anyone's interested in that, I'll be speaking about that on Saturday, day after tomorrow. There's a 2-day event tomorrow at the University of Utah at the Wallace Stegner Center about the legacy of Rachel Carson. So if anyone's interested, you can come and hear all about that on Saturday. These physicists cast doubt on the science behind every one of these issues. And in every single case, case after case after case, the pattern was identical. To insist that the science was uncertain and therefore it'd be wrong for any action to be taken by the government, or really by anyone else for that matter. But the main focus for them was on the issue of the government regulation and intervention. Now, to find out how they did it, you'll have to buy the book. What I want to talk about in the remaining time is why they did it, and especially why this has gained so much traction in the United States, particularly on the conservative side of the American political spectrum, so that Arnold Schwarzenegger stands virtually alone among his Republican colleagues in defending the reality and significance of climate change and the importance. And by the way, Arnold, in California we call him Arnold, it's not considered disrespectful. I was at a conference just a few weeks ago that he spoke at. He hasn't backed off this whatsoever, and he and Jerry Brown got up together to talk about AB 32, and it was an incredible moment in American politics because of how polarized things are in most of the United States, to see our current Democratic governor, our former Republican governor, stand on the stage together and commit to continuing to work on this issue together. So that's just a nice aside. Okay, so why? Well, the short answer has to do with the ideology that academics call neoliberalism, or George Soros has called free market fundamentalism. And it really comes out of the Cold War. It comes out of the success of the United States in winning the Cold War and the discreditation of communism, socialism, and anything that seems to challenge the idea of the power of the free marketplace. So modern neoliberalism focuses on the idea of deregulation and releasing the so-called magic of the marketplace, the idea that the most effective thing that a government can do to generate economic prosperity is to simply let the free market do its thing. It came to prominence at the end of the 1980s, so right at this period, the end of the Cold War, led by Margaret Thatcher in the United Kingdom and Ronald Reagan here in the United States. But it's really important to recognize that it wasn't just Republicans and Tories who advocated deregulation, it was Democrats and liberals as well. So throughout the 1990s, the idea of deregulation was promoted as part of the so-called Washington Consensus that was led by Democratic President Bill Clinton and UK Labour leader Tony Blair. Right up until the global financial collapse of just a few years ago, among European and North American political leaders, there has been a political consensus on the virtues of deregulation. I'm going to skip this because I think it's more detail than we probably need, but here in the United States, a key part of the story is the influence of the economist Milton Friedman, who wrote a very important book called Capitalism and Freedom, published in 1962, really at the coldest moment of the Cold War, right around the time of the Cuban Missile Crisis. And Friedman was very, very influential in neoliberal thinking, both in the United States and elsewhere. And this, in a sense, is really the crux of the argument. It's the argument that political freedom and economic freedom go hand in hand. Because if you give up your economic freedom by allowing the government to regulate the marketplace, then it's only a matter of time before you'll lose your other freedoms as well, that you'll be on a kind of slippery slope to socialism, or what von Hayek, who was Friedman's inspiration, called the road to serfdom. Now, the contrarians in our story took this argument even one step further, that environmentalism was the road to serfdom. Why? Well, because environmentalists, particularly in the 1980s and 90s, generally were arguing for government regulation, whether it was regulation of tobacco, regulation of the pollution that causes acid rain. And so Friedman and his colleagues argued that it was only a small step from regulating tobacco to regulating your life, losing your religious freedom, losing your political freedom, losing your freedom of speech. So it's a slippery slope argument. Now, this idea is articulated in many, many different places, but perhaps most clearly by a fourth scientist in our story who also joined this cause in the 1980s, and that was a physicist named Fred Singer. Like the others, he was a physicist who had built his career during the Cold War. In fact, he was the proverbial rocket scientist, having been the first director of the US Weather Satellite Service. And like the others, he challenged the scientific evidence of acid rain, global warming, the ozone hole. And the other three are all deceased now. He's still alive and still active. If you Google him, you can find him attacking me and saying I'm a fraudulent historian. And like the others, he also defended tobacco and also challenged the scientific evidence of the harms of tobacco. In this case, the debate that took place in the 1990s over the harms of secondhand smoke. In the early 1990s, Fred Singer worked with the Philip Morris Tobacco Company to attack the U.S. Environmental Protection Agency over the issue of secondhand smoke. And here's a small aside. This is one of my favorite stories. The tobacco industry was very clever. They hired very, very smart advertising and PR executives. They didn't make a lot of mistakes, but they did make one here. So people generally referred to this problem as secondhand smoke, that if you inhaled the smoke of a person next to you, you were getting the same carcinogens, the same toxins as the person smoking, and therefore your health would be at risk too. But the tobacco industry didn't like the expression secondhand smoke because they reckoned Americans didn't like secondhand things. So they started this whole campaign to call it environmental tobacco smoke as well. And they thought that sounded much more friendly and benign because everyone liked the environment. The only problem was that it invited the scrutiny of the Environmental Protection Agency. So the U.S. Environmental Protection Agency took up this issue. And Singer and a lawyer named Kent Jeffries, who worked for the Cato Institute, attacked the EPA in a report entitled EPA and the Science of Environmental Tobacco Smoke. Now, what had the EPA found? Well, the EPA had convened a scientific review panel that had reviewed over 6,000 peer-reviewed articles in oncology, epidemiology, public health, studies that involved people, studies that involved lab animals, study that involved the wives of smokers, a whole set of diverse scientific data, and concluded that these data showed that secondhand smoke was a Class A or proven carcinogen, that if you lived with someone who smoked, that you were exposed to the same hazard and you could get lung cancer too, even if you never smoked a cigarette a day in your life. This result was affirmed by the U.S. Surgeon General and by leading scientific and public health organizations around the world. So why would a rocket scientist challenge over 6,000 peer-reviewed studies on the harms of secondhand smoke? And I should point out also, these studies also showed In fact, one of the most important things about these studies was the harms that it showed to children. The studies showed that children who lived in homes with secondhand smoke were much more likely to get bronchitis, pneumonia, and emphysema, which can often be fatal in young children, and also that secondhand smoke is a cause of sudden infant death syndrome, which in fact it is. There's been a lot more work on that today, and yet even today many Americans don't know that secondhand smoke causes sudden infant death syndrome. Many doctors don't even know it, in part because the tobacco industry suppressed a lot of this information, but that's another story. So why would a rocket scientist defend a product that killed babies in their cribs? Well, we don't have to speculate because Fred Singer answered that question in his own words. He said, if we do not carefully delineate the government's role in regulating dangers, there's essentially no limit to how much government can ultimately control our lives. So it's a slippery slope argument. Today smoking, tomorrow the Bill of Rights. But like all slippery slope arguments, it's a logical fallacy, right? It's the logical fallacy of the slippery slope, that just because I control one hazard, it means I'm going to take over the world. But that's essentially the argument. Luntz, who we started this talk with, made a similar point while challenging climate science in the Wall Street Journal in 2003. Once Republicans concede that greenhouse gases must be controlled, it will only be a matter of time before they end up endorsing more economically damaging regulation. So what we see here then in this argument and throughout all of the stories that we tell in our book is that these debates are not about the science. These debates are not being triggered by inadequacies in the science, by insufficient data, by work that isn't peer-reviewed. These debates are not about the science. These debates are about control, about government control of marketplaces and by implication of individual liberties, and whether or not the government should intervene to protect people and the environment from hazards, from dangers. So it's really about values. It's about the role of governance and where you draw the line between an appropriate government protection and an inappropriate government interference. So in their writings, you find that contrarians frequently assert that environmentalists, and by implication scientists or historians working on environmental issues, have a hidden agenda, and that hidden agenda is anti-business, anti-free market, and anti-technology. I'm obviously elaborating more than I normally do, so I'm just trying to go through this quickly, but I'd just like to point out that the implication that environmentalists are somehow socialists is particularly ironic in the United States when you think about the history of the environmental movement, which was founded not by socialists and communists, but by progressive Republicans like Teddy Roosevelt, Gifford Pinchot, and as I like to point out, my favorite communist, John D. Rockefeller. Indeed, throughout the 1920s, right up until the administration of Richard Nixon in the United States, there was a bipartisan consensus on the importance of environmental protection in the United States. All of the major pieces of environmental legislation that provide the framework of environmental protection in the United States today were all passed by large margins. In fact, the Wilderness Act passed the U.S. House of Representatives by a vote of 373 to 1. So that tells you something about changing politics in America, too. But in some ways, this is a bad luck story, because that bipartisan consensus began to break down in the 1980s with the rise of neoliberalism and the end of the Cold War, and it began to break down at just the same moment that scientific evidence, working completely independently, began to reveal serious problems such as acid rain, the ozone hole, and global warming, problems that individuals by themselves could not solve. I could stop driving my car tomorrow, but by myself, I can't stop global warming. By myself, I can't stop acid rain. And by myself, I can't stop the person next to me from smoking cigarettes that could kill me and my children. So these were all problems that seemed to demand some kind of collective response, some kind of government action, some kind of regulation. And these issues emerged just as the Reagan administration here in the United States and Margaret Thatcher in the United Kingdom were arguing for less government and less regulation, precisely as advocated by the Chicago economist Milton Friedman, shown here meeting the president. And this, Eric Conway and I argue, put the Reagan administration and later the entire neoliberal consensus, not just Republicans, but a lot of Democrats in this country too, on a collision course with modern science. The great anthropologist Ashley Montagu said in the 1950s that reality has a well-known liberal bias. That was a very controversial comment when he made it. It's controversial even today. I would put a slightly different spin on it. I don't think that reality has a liberal bias, but I do think that what reality has pointed out is market failure. That is to say, it's pointed out the limits of the free market. So if we look about the question of climate change, what we see then is that scientific evidence doesn't tell us what to do about global warming, but it does tell us that we need to do something. And whether it's a carbon tax or an emissions trading system or banning a product outright, as we did with the CFCs that destroy stratospheric ozone, we have to do something that we can't just do alone as individuals. And that really is the crux of the problem. It's about recognizing the limits of free market capitalism, recognizing the limits of individual action, and recognizing that some problems do call for government intervention. Now, Ronald Reagan certainly had a point. Government regulation is not the solution to every problem. And some environmentalists are socialists, not very many in the United States, but certainly in Europe there are some. And moreover, the cutting edge of science is always unsettled. There is always uncertainty, there's always room for doubt. But that doubt, that legitimate uncertainty, does not mean that DDT, acid rain, the ozone hole, and secondhand smoke weren't all real problems needing real solutions. It doesn't mean that the science was wrong. But what it does mean is that free market capitalism, like any human system, has its limits. And those limits in these cases are what the economists call negative externalities. That is to say, costs that accrue to the people who did not reap the benefits of the activities that generate them. So if the person next to me smokes and enjoys smoking, well, that might be his choice. But if that smoke kills me or my children, then I'm experiencing a very serious negative externality. And environmental damage is the textbook case of a negative externality. And this is the common thread, then, that unites what seems to be otherwise diverse stories, stories that otherwise, in the face of it, might not seem to have anything to do with each other, like tobacco, smoking, and global warming, because they all involve market failures. They're all examples of behaviors that generate large external costs and therefore provide a potential justification for some kind of government action. And this is why Nicholas Stern, the former chief economist of the World Bank, has called anthropogenic climate change the greatest and widest-ranging market failure ever seen. So it's not surprising then that environmentalists, liberals, and Europeans were quick to accept the reality of these problems, and that conservatives, libertarians, and Americans have, by and large, been slow to accept them. As Judge Richard Posner has argued, behavior that generates large external costs provides an apt occasion for government regulation. So how we feel about regulation, how we feel about governance, is going to affect how we feel about that behavior, whether it's smoking or burning fossil fuels. We're all more likely to accept evidence consistent with our pre-existing worldview, but as Posner has pointed out, a rational decision maker starts with a prior probability, but adjusts that probability as new evidence comes to his attention. History tells us that scientists have known for a very long time that global warming from burning fossil fuels could occur. And for more than 20 years now, evidence has been mounting that it is occurring, evidence that our scientists now tell us is unequivocal. It's sometimes said that communism failed because prices didn't reflect economic realities. Will capitalism fail because our prices don't reflect ecological realities? So to conclude, the Industrial Revolution was a good thing. It brought the developed world 150 years of unprecedented prosperity. But it also brought some consequences in its wake. It also brought a bill. And part of that bill is global warming, and that bill has now come due. And as the novelist Kim Stanley Robinson has pointed out, the invisible hand never picks up the check. Thank you very much. Oh, sorry, you can't read the bottom, but it says, "I'm sorry, Harold, but I'm reducing our carbon footprint."
Okay, if it's okay, we'll go ahead and start the Q&A then. Please wait for the microphone and speak clearly into it. That helps with our recording of this lecture for people who will later watch it on the internet.
So I'm just trying to see if I'm understanding your main conclusion. Are you just basically trying to clear the bad rap for the argument against global warming? Or maybe I'm not understanding it right.
Okay,
But
okay, I think I understand. Well, I mean, there's a few different things. It's not an argument for global warming, right? Nobody's in favor of global warming. So there's, in a sense, you're right, there's two parts of the argument. The first part is for people to understand that the scientific evidence of the reality of climate change caused by human activities is overwhelming, and that evidence has been building for 150 years, and that as recently as 1992, that evidence was considered uncontroversial by political leaders as diverse as Al Gore and George Bush. Something happened after the UN Framework Convention. Something happened that turned the Republican Party in this country against the scientific evidence, and that persuaded a lot of us that there wasn't a scientific consensus when there really was. And so the book is really an attempt to answer that question about what happened. And so in the book, we outline the various strategies and tactics that were used to cast doubt on the science, show how those strategies and tactics were originally developed by the tobacco industry, so that gives you some idea about their pedigree, and then to try to understand what is driving this. Why would intelligent people, because obviously these people are highly intelligent, why would intelligent people do this? And so what we're trying to explain and show is that they become caught up in an ideological system that essentially blinds them to the reality. They become so frightened by the idea of a threat, that a threat of intrusive government, that it really clouds their thinking. And so it's that worry, that anxiety about government intervention that drives the doubt-mongering campaigns. And I would argue then, so this is, I guess, a little additional point that maybe was implicit, but I can make it explicit, that in different forms, many of us have bought into that anxiety. So most of us are not cold warriors. Most of us didn't build the hydrogen bomb. Most of us do. I mean, public opinion show that if you ask people, do you think that we need to have a government? Most people say yes to that question. If you ask people, do you think the government has a legitimate role in protecting public health? Most people will say yes to that question. If you ask people, do you think the government has a legitimate role in protecting the environment? Most people will say yes to that question. But yet, even though we say yes to all those questions, when someone gets up in public and says, but if we control climate change, it will wreck the economy, and the government will take away your right to drive your car, and this is a liberal plot to control your life, which Newt Gingrich said only a few weeks ago. I mean, I have a lot more material. I'm always, playing with which material to use. But I mean, just 3 weeks ago, Newt Gingrich said the climate change is a liberal plot to control your life. So when people say that, I think a lot of us do get worried because we don't want the government to control our lives. We don't want the government to tell us what to do personally and how to live, and we certainly don't want the government taking away our religious and civic freedom. But it's an irrational argument because it's a slippery slope argument that isn't actually supported by the facts. The scientists who work on climate change care about their religious and civic freedom just as much as any other American person does, but they also care a lot about what's going to happen if we don't stop climate change from getting worse.
Hi. Does the banning of CFCs and the progress that we've made with the ozone layer give you hope for helping us reduce our carbon footprint?
Yeah, it does, and that's a great question. And people often ask about the CFC story because of all the stories in our book, that's probably the most successful example of governments acting intelligently on the basis of scientific information. And in some ways, it's an interesting story. It's a good example because it's the most extreme, actually, of all of them. CFCs were banned outright. The government made CFCs illegal. It is illegal to manufacture CFCs in the United States. It's illegal to use them. So that's the most extreme possible government action there can be, an outright ban. And yet we all accepted that. So we could ask the question, well, why did we accept it? And I think part of the answer to that is that the DuPont Corporation did the right thing. The DuPont Corporation, who were the largest manufacturers of CFCs in the world, accepted the evidence, partly because their own in-house scientists told them that it was true. And after a brief initial period in which DuPont and other corporations did briefly challenge the scientific evidence, which we talk about in the book, then they backed off and said, okay, we won't make this product anymore, and we can do other things to make a living. So it's an important example because it shows it's possible for the corporate sector to do the right thing. It's possible to earn a living without destroying the ozone layer, without harming people. It's possible to make a living in a way that's moral. But it's also an important story because at the end of the day, most of us didn't rely on CFCs to live our daily lives, and there were alternatives, whereas we all rely on fossil fuels every day to get to work, to light our houses, to keep our food cold. I mean, we rely on fossil fuels for everything, to be sitting here in this room, to give my PowerPoint presentation, to print my book. So that's where I think the CFC story, though, is both optimistic but a little pessimistic. It's optimistic because it shows we can do it, and giving up CFCs did not cause us to lose our religious liberty, right? It's very important to make that point. I feel that I'm just as free a person now as I was in the days that I had hairspray, right? But climate change is a much, much bigger problem. And so we have to think about substitutes. So I actually think the CFC analogy is the perfect analogy, because really what it becomes is, what are the substitutes, and how do we make the transition into a green economy? And I'm actually optimistic because I believe technologically the solutions exist. I think there's good evidence they do. But politically, we're at an impasse because we have a lot of people who deny that there's even a problem.
Well, it's a very busy season here at the Kennedy Center, and we have another lecture that's
okay.
hoping to move in. But we'll take one last question here on the floor, and then we can continue the discussion out in the foyer after that.
So I just had a question about, so I'm from Arizona, and so it's hot all the time. But so here I've heard that this is like a really light winter compared to other winters. And I know Arizona last winter was really, really wet. And are small changes like that where it's just like seasons that are wetter than normal or hotter than normal, would you consider those effects of climate change?
Yeah, that's a great question, and it's a really good question. It gets into this domain of, the complexity of the science and how best to explain it. So I think the best way to think about that is patterns. Climate, by definition, is about the pattern, right? The climate of a place isn't what the weather is on any one day. It's what the overall pattern is. And what the scientific evidence clearly shows is that the patterns are shifting. So if you look at, say, winter here in Utah or in the American West, what we see is that winter is getting shorter. Spring thaws are coming earlier. Now, for some of you who live down in Salt Lake and you welcome spring, that might seem like a good thing, but it means that the ski industry, for example, is looking at fewer ski days every year. And that's extremely well documented, the earlier spring thaws. We also see that there are shifting patterns in whether or not precipitation falls as rain or snow. So in California and the Sierra Nevada, there's quite strong evidence that the pattern is shifting, that more of the precipitation is falling as rain than snow. And that's partly because spring is coming earlier, so there's less snow on the summer end, and also the winter is coming later, so there's less snow at the front end. Now, you might argue that that doesn't really matter very much, or it only matters for the rich people who get to ski, but actually it matters hugely in California because a huge amount of California water supply comes from the Sierra snowpack. And the Sierra snowpack is a natural reservoir. The water is stored, and then it gradually thaws and supplies the downstream reservoirs in the springtime. If that water begins to fall as rain and not snow, then that storage capacity gets lost. And that means the state is looking at billions of dollars in costs to build artificial reservoirs, which will cost the taxpayers a heck of a lot of money, a whole lot more than the natural God-given snowpack, right, the natural God-given reservoir. And it also means that there'll be a lot more damage to the rest of the environment as we have to dam rivers and lakes to create reservoirs instead of natural free-flowing rivers. So it reverses 30 years of progress on issues like salmon and whitewater rafting and recreation and a whole lot of other things. So all these things have a lot of consequences, and the overall patterns are very clear that we are seeing exactly the things that scientists predicted. More rain, less snow, shorter winters, more droughts, more severe droughts. I could go on for a long time. We've had more severe droughts in California, and this was an example that actually Governor Schwarzenegger talked about. You said you're from Arizona. I mean, sometimes people say the most extraordinary things. So there was a governor a few years ago who said, well, if it gets hotter, we'll just turn on our air conditioners. Well, in California, in the heat wave of 2006, people died in their homes in the Central Valley. People who owned air conditioners died in their homes because they couldn't afford to turn the air conditioners on. So this also gets to the question of vulnerability. Sure, rich people can turn on their air conditioners and be fine, but poor people could die in their homes in a heat wave even if they had an air conditioner. So thank you all so much for coming.